Hello friends, this video on equilibrium part 16 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's take one more example. One of the reactions that take place in producing steel from iron is the reduction of iron by carbon monoxide to give iron metal and CO. This is the reaction FeO plus CO gives Fe solid plus CO2 gas. Please note there is a solid part here now. There is a solid part here. It's a little tricky question. And the Kp is 0.265 atmospheric pressure at 1050 Kelvin. We have to find the partial pressure of CO and CO2 at this temperature if the initial pressure of CO and CO2 are given. Let me write the equation first. FeO solid plus CO gas in equilibrium with Fe solid, CO2 gas. This I don't want, I don't care because it's solid. Initial at T is equal to 0, the partial pressure of CO was 1.4 atm, CO2 was 0.8 atm. Okay. Now the question is, will the reaction go in this direction, this direction? I don't know. Let's find the value of Qp then. Qp is what? Concentration of CO2 by concentration of CO, pressure of CO2 by pressure of CO at T is equal to -0. What is the pressure of CO2? That is 0.8 by 1.4, that is 0.571. What is the value of Kp? Kp is 0.265 atm. This will also be in atm. So if you compare these two values, you can see that Qp is greater than Q is greater than Kp. That means what? That means reaction will go in backward direction. Reaction will go in backward direction. Correct? So let's assume that at T is equal to equilibrium, this becomes 0.8 minus P. This will become 1.4 plus P. Correct? So my Kp will be what at equilibrium? Pressure of CO2 by pressure of CO. Or what is the value of this? 0.265, and what is this pressure of CO2? That is 0.8 minus P, and this is 1.4 plus P. You solve this, you get P is equal to 0.339 atm, because it is an atm, everything is an atm, so it will be atm. Thus I can say that my pressure of CO at equilibrium is what? 1.4 plus P, 1.4 plus P. That is nothing but 1.4 plus 0.339 atm, and that is nothing but 1.739 atm. Similarly, pressure of CO2 is what? 0.8 minus P, 0.8 minus P, that is 0.8 minus 0.339 atm, that is 0.461 atm, and that is my answer. So I could easily find the partial pressure of CO and CO2 at. So the first thing I did was I found the value of Q to determine the direction of the reaction. I found the Q is greater than Kp, so that means the reaction is going in this direction. So I assume the partial pressure of CO2 will be reduced by P, and the partial pressure of CO will be increased by P, because all are having same stoichiometric coefficient, so it will be P and P. With that, I use this equation Kp is equal to partial pressure of CO2 by CO, found the value of P. If I had the value of P, I can easily find the partial pressure of CO2 and partial pressure of CO at equilibrium. Let's take one more question. The equilibrium constant Kc for this reaction N2 plus 3H2 gives 2NH3 at 500 Kelvin is this Kc. At a particular time, the analysis shows the composition of the reaction mixture is this 3 moles per liter N2, 2 moles per liter H2, and 5 moles per liter NH3. So I have N2 plus 3H2 gives 2NH3. At T is equal to some time T, it says that N2 was 3 moles per liter, H2 was 2 moles per liter, and NH3 is 0.5 mole per liter. The question is the reaction equilibrium? So at T is equal to T I am finding, so I'm looking for QC, that is NH3 square by N2 by H2 to the power 3. So you put all the value at T is equal to T, right, at time T. So this becomes NH3 is 0.5 m to the power 2, this becomes N2 is 3 m, and this becomes 2 m to the power 3. So you solve this, you get 0.01404 m to the power minus 2. So if you see this value is, you compare this with Kc 0.061, you see that this value is less than Kc, right? So Qc is less than Kc, it is not equal to Kc, so it is not in equilibrium, right? So it is not in equilibrium, not equilibrium. So if not equilibrium, which direction it will proceed? Since Q is less than Kc, it will go in forward direction, right? So Q is less, that means my less products. If less product, that means it will go in forward direction. Correct? So the question says at 1127 Kelvin, 1 atm pressure, gaseous mixture of CO and CO2 is in equilibrium, and where CO has 90.55% by mass. There is a mixture. You need to find the Kc. Note, even if you assume, let's suppose there are 100 grams of, this is, we have to ignore, the 100 grams of CO2 and CO, let's suppose, then in that case, my 90.55 grams is what? CO, and my CO2 will be remaining, that is 100 minus 90.55, that is 9.45 grams of CO. Let's assume I have 100 grams of total mixture. So my T is equal to 0, this is my grams. But grams is something which is useless for me. I have to find something in moles. So moles of CO will be what? 90.55 is the weight by atomic weight of CO, that is 28. And moles of CO2 will be what? 9.45 grams by atomic weight, that is 44. So you solve this, this is nothing but 3.23, and this is 0.22 moles. This is the mole of CO and CO2 I have got. But I have to find moles per liter, right, concentration, but the liter is not given. So what I can do is, since the pressure, total pressure is given, I can find the partial pressure, and I can find Kp. See, why I am not finding Kc now is the liter is not given, the volume is not given. Okay. So let me find partial pressure. So partial pressure of CO will be what? 3.23 moles by total mole is 3.23 plus 0.22 into 1, that is 0.94 atm, and partial pressure of CO2 will be what? 0.22 by 3.23 plus 0.2 into 1, that is 0.06 atm. This is my partial pressure of CO and CO2. So with this I can find Kp easily. Kp is what? Partial pressure of CO to the power 2 by partial pressure of CO2. Correct? So what is this? This is 0.94 square by 0.06. You solve this, you get 14.25 atm. That is the value of Kp. I have the value of Kp, I can find Kc very easily. See, Kp is equal to Kc RT to the power delta n. Delta n is what? 2 minus 1, 1. So let me put the value. Kp is what? 1.14.25 atm is equal to Kc, I don't know. R is 0.0821. T is given 1127 Kelvin. Delta n is 1. You solve this, you get Kc as 0.154. Since it was atm here or bar here, atm, so it will be moles per liter. I told. And also if you see delta N is 1, so the unit will be moles per liter. This is my case. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.